In this video, we're given some functions, and we want to determine whether each function is either even, odd, both even and odd, or neither. So these are the functions here. You can pause the video here if you want to try these, and then I'll be back. So let's look at two examples just to review. F of x equal to x squared has this particular graph, or close to it. F of x equal x to the third has this graph here. And this particular graph is symmetric with respect to the y-axis. Notice if I fold one half, either the left or the right side, over to the other side, they coincide. If I fold this over to this side, vice versa, they'll coincide. That's symmetry with respect to the y-axis. You can have a similar thing with the x-axis, but right now we're focusing on some other things. This one over here, f of x equal x to the third, has symmetry with respect to the origin. So that means that if I were to take this graph and rotate it counterclockwise 180 degrees, it coincides. This would coincide with that. And of course the center is the midpoint of any 2 points. You pick this point here and this point over here, the center will be the midpoint. So you can see that if I pick one point, let's say this is 2 units here. So if I go up 2 squared, this would be the point 24. You notice on the opposite side, because of the symmetry, we would have the point -2 and 4. So if you have symmetry with respect to the y-axis, if you have a certain point, in this case 2, 4, on the graph, then the point -2 and 4, or xy is on the graph, then -xy will be on the graph, if it's symmetric with respect to the y-axis. Over here on this one, let's say I go over 2 this way. To the third is 8, so this point 2, 8 would be in the graph. And if I go back this way, the point -2 and 8 would be in the graph, or I should say -8. So that means then, okay, 2, 8 is on the graph, so -2, -8 is on the graph. So anytime then, if you have symmetry with respect to the origin, anytime the point xy is on the graph, then the point -x and -y will be in the graph. So that's why we can say then, based on this, if a function is even, then if you evaluate the function at -x, you get the same thing as f of x. So you can say that here, f of 2 and f of -2 are the same. Gives you the same thing. +2 or -2 still comes out the same over here. At x equal 2 we get 4. At x equal -2 we also get 4. Now in this case over here, this basically is implying then that if you evaluate the function, an odd function, at -x, that's going to give you the same thing as minus, or the opposite of the function. +x. So you can see here then, if I evaluate this function at say -2, that'll be the same thing as f of 2, f of negative 2, of course, is negative 8. This will be the same thing as f of 2. Let's see, f of 2 is 8, so it's the opposite. So there's your definition. Any function that satisfies this definition is even. And that means it's symmetric with respect to the y-axis. Any function that satisfies this definition is odd. And it's symmetric with respect to the origin. Okay, so now we can do this. We want to test the first one. So we'll write f of minus x. And all you have to do is replace the x by minus x. So think of put a parenthesis where the x is and put a minus x there. So minus x to the 4th power is x to the 4th. Because it's an even exponent, it cancels the negative. So now this one here, put a minus x where the x is. So because this is an odd power, the minus stays. And it's going to cancel this minus, so that'll be a plus. And this will be 4. X to the 3rd. And then again, parentheses where this x is, put a minus x. That'll just stay a minus x times 3, so it'll be a minus 3x. Now when you do that, if you get the same function back, then it's even. Well, you can see we didn't get the same thing back. Got x to the 4th, and this changed to a plus. So it's not even. Now if you get the same thing back multiplied by a negative, or the opposite of what you started off with, then it's odd. Well, we didn't get the opposite of what we got to start it off with, because otherwise you'd have a negative here. And these signs would be changing. The first one then is neither. It's neither. Number 2, evaluate the function at minus x. And then compute, simplify, and if you get the same function back, this is g here, get the same function back, then it's even. If you get the opposite of what you started off with, then it's odd. So let's go. Parentheses where the x is, and just plug it in there. So minus x and parentheses there, and this to the 4th. Well, that's going to stay x to the 4th, so that's not going to change. And parentheses where the x is there, minus x squared, the negative cancels, so that stays 7 and x squared. And this one doesn't have an x, so it's going to stay minus 8. So I get the same thing back. G of minus x is the same thing I started out with, which is g of x. So this one is even. The first one was neither even or odd. This one is even. Now one shortcut you can use if you have polynomials, if all the exponents are even, just look at the exponents. If it's a polynomial, okay, this only works for a polynomial. If it's a polynomial, look at all the exponents. If they're all even, then it's an even function. So look at this, x to the 4th. Okay, exponent is 4, it's even. X squared, doesn't matter what the coefficients are. You look at the exponents. So 4 is even, 2 is even, and you say minus 8. Well, that's x to the 0. If you put an x there, it'd have to be x to the 0, and 0 is even. So that one is going to be even. If they're all odd, say I make this a 3. Instead of a 4, you have a 3. Instead of an x squared, you have a 1. And say I leave out the minus 8, then you got all odd, it's going to be odd. Odd function. Now if it has a mixture of both, then it's neither. So notice the first one, power is 4, that's even. The next exponent is 3, that's odd, and of course 1 is odd. As long as there's a difference. they're not all even or odd, then it's neither. Okay, that's for polynomials. The next one's not a polynomial. So that's not going to work in this one. So in this one is h of minus x. Again, we evaluate the function at minus x. If you get the same, if you get h of x back, then it's even. If you get the opposite of h of x, then it's odd. Otherwise, it's neither. So let's put a minus x where the x is. Okay, e to the x will give me e to the minus x. This will be plus e. Okay, so put a minus x where the x is, so it'll be a minus x there, and then but it's got a negative in front of it, so it'll be minus a minus, so it'll be a plus. That's over 2. Did we get the same thing back? Yeah, different order, but it's the same thing. Commutative property of addition. This is e to the x plus e to the minus x. This is e to the minus x plus e to the x. Okay, commutative property for addition, that works. So this one is even. We did get the same thing back. This is the original h of x. So that one's even. Okay, the next one's a rational function. So let's see, use the definition f of minus x. And then I put a minus x where the x is. So here in the numerator, put a minus x. So this would be like this, minus x. And then this to the third. And then it's got a minus. So this actually gives me, because this doesn't add power, when I take this to the third power, it's going to say minus x to the third, and then a minus makes it a plus x to the third. So in the numerator, then I'll get x to the third. In the denominator, it'll be 3. In parentheses here, put x to the, or minus x for the x is here in parentheses, and you square it. It's going to stay 3x squared. And the other next term there, minus 9, doesn't have an x, so that's going to stay. So I didn't get the same thing back. So it's not even. But did I get the opposite of what I started off with? Yeah, because if I multiply that by a negative, that's the same thing as what I started off with. The negative of this gives me that. So this one is odd. Let's clear this one. Let's look at the next one. F of x equal to 0. So let's look at this. F of x equal to 0 is just the x-axis. Okay, so horizontal line, in this case, turns out to be the x-axis. So let's say f of minus x. What is f of minus x? Well, since I have a constant on the right side 0, doesn't matter what I plug in there, I'm always going to get 0. So f of whatever is always going to be 0. Did I get the same thing back? Yes. So it is even. Now, did I get the opposite of what I started off with? So I know, based on that f of minus x does equal to f of x but f of minus x also equals to minus f of x. Because if I put a If I put a negative in front of that, that's still 0. Minus 0 and plus 0. Put a negative or a positive in front of that 0, it's still going to be 0. So it is true that f of minus x equal to f of x. It is true that f of minus x equals to minus f of x because the function is 0. So this is the only function that is both even and odd. It's symmetric with respect to the y-axis. It's also symmetric with respect to the origin. Okay, because it turns out to be the graph is just the x-axis. And on this one here, g of minus x, replace the x by minus x. In the numerator, I just get minus x. The denominator, because you have x squared, a minus x there where the x squared is, because of the square gives me x squared, so this stays the same, x squared minus 4. Did I get the same function back? I didn't. So it's not even. But did I get the opposite of the function I started off with? Yeah, because this is minus. I take out that negative over. That'll just give me x over x squared minus 4. That gives me g of x. G of minus x does give me the opposite of g of x. So this one, the last one, number 6 here, is odd. Thanks for watching. We'll see you next time.